Hello. Okay, so the purpose of this video is to basically describe how to graph polynomials using the sign chart method. So these are the same problems that we worked on earlier this week. So previously I showed you guys how to choose a whole bunch of x's, and then you figure out what your outputs, and then it became this process where you had to plot a whole bunch of points and connect the dots. And some of you guys realized that method could get kind of tedious. So what I'm going to show you here is a shorthand method, just a little shortcut rather than plugging in a whole bunch of points. Okay, so this first part says we're going to draw a rough sketch of the graph. So what I'm going to show you is just a general graph of what this might look like. And after showing you that sketch, I'm going to show you guys it's going to be the same thing after plugging it into Desmos. Okay, so as you remember from last class, what we did is we first needed to factor this expression. So if we look at this expression, what we needed to do is we needed to find two numbers that multiply to 36, and that's a negative 12. So if we figured out what those numbers were, it would be negative 6 and negative 6. Okay. So putting that together, this part, becomes this. Now if we wanted to, we could also write this expression as a square because these factors are the same. Okay. Then what we wanted to do is we're going to set each of these factors equal to 0. So you're just setting x minus 6 equal to 0, and you're setting x plus 2 equal to 0 because we wanted to figure out our x-intercept. In other words, where this function is going to touch across the x-axis. So what we're going to do is we're going to add 6 to both sides here, and this one says we're going to subtract 2. Okay, so this is our x-intercepts, so we can plot this. So we're going to plot 6 comma 0, and then we're going to plot negative 2 comma 0. Okay, so now what we're going to do is we're going to use a sign chart to try and figure out where our function is above or below the x-axis. So first we need to consider this region here. So that means we're going to consider any value here, so just any x in this case, that is going to be less than negative 2. Then we're going to also consider this region. So we have this region here, which is between negative 2 and 6. Okay, so we're just going to choose any x between negative 2 and 6. And last, we're going to choose an x, something in this region. Okay, so we're going to choose an x greater than 6. Okay, this is where I told you guys, okay, just choose numbers at this point. Just choose any x less than negative 2, so anything here, so you could do is negative 4 if you wanted to. You could choose anything between negative 2 and 6, which I guess you could use 0 if you wanted to. And then any x greater than 6, so you could choose something like 8. Okay. So for this next part here, what you're doing is we're going to put either a plus or a minus symbol in these columns here. So a plus will indicate that the output is going to be positive, and then a negative sign will indicate, or minus sign will indicate that the output is negative. So let's just go and do that. So if I put negative 4 in here, right? Negative 4 minus 6 is negative 10, and if you did negative 10 squared, right? This should be a positive number, which is going to be 100. So you just got to ask yourself, well, is 100 a positive or negative number? In this case, it's going to be a positive number. Okay. Then we're going to put negative 4 in here. So you have negative 4 plus 2, so that's going to be negative 2. So negative 2 would be, you guess, is it positive or negative? In this case, it's going to be negative. Okay. So next, what we got to do is, you can see here, this is part of our function, we're just going to multiply the signs. So we're multiplying these two. So we're multiplying a positive and a negative number. So let me just write that for you guys. So we're going to multiply the signs. Multiply the signs in the previous columns. Okay. So if you multiply a positive and a negative number, this means our output is going to be a negative number. So what that means is where x is less than negative 2 is under the x-axis. Okay. Next, what we're going to do is we're going to choose an so we chose 0. So you plug 0 into here. 0 minus 6 is negative 6. So you're thinking negative 6 squared. Is negative 6 squared positive or negative? So that should be positive because negative 6 times negative 6 is going to be positive 36. Then you're going to plug 0 into here. 0 plus 2 is positive because 2 is a positive number. A positive number times a positive number indicates that our output is going to be positive. So this means this interval from negative 2 to 6 is above the x-axis. Okay? Then we have the last region where x is greater than 6. So let's say we choose 8. We plug 8 in here. 8 minus 6 is 2. 2 squared is going to be 4. 4 is a positive number. Plug 8 into here. 8 plus 2 is 10. 10 is a positive number. It's going to be the exact same thing that we have up here, right? If you multiply two positive numbers together, your output is positive. So that means the region where x is greater than 6 is indeed above the x-axis. So as you can see, with this method that I showed you guys right here, you didn't have to calculate any y values. So let me just take a little bit of time just to prove this to you guys. So this was our original function that we started with, right? So if I just type in d of x equals x squared minus 12x plus 36 multiplied by x plus 2, right? So that's just shown here. As you can see, our graph kind of has that same shape, yeah? It starts from the bottom, and it goes up, comes down, and eventually comes back up, yeah? If you wanted to, you can adjust the window. Let me just do that really fast, I guess. And this might be like negative 10 to maybe 150 or something. Yeah, there we go. So you can see, this has the same shape as this. Okay, so onward to the next example. All right, so we are back. Okay, so now what we're going to do is we're going to draw a rough sketch of the function that you see here. Okay, so the first step, what I see here is we want to factor this expression. Yeah. So if we factor this, what we got to do is we got to find two numbers and multiply to negative 24 and add to negative 2. So those numbers are going to be negative 6 and 4. So when we factor this piece becomes this here. Okay. So in order to solve for x-intercepts, right, so you set this piece equal to 0, right? So you have x squared equals 0. So it's just x equals 0. And if you set x minus 6 equals 0, you add 6 to both sides. And this one, if you set this equal to 0, you're going to subtract 4. So that's how you get your x-intercepts at 0, 6, and negative 4. Okay, so what you're going to do is you're going to go ahead and plug all those x-intercepts in. So you have x is 0 here, x is 6, and then x is negative 4. Okay. So there are 4 regions for us to consider. There's this region here. So this means we're going to choose an x less than negative 4. Yeah. We have this region here. Oh, let me make that a little bit nicer. This region here. So you're going to choose an x between negative 4 and 0. We have this region here. So you're going to choose an x between 0 and 6. And last, we're going to choose an x this way. So we're going to choose an x greater than 6. So now what we're going to do is we're going to choose x's that fit this criteria. So if you choose an x less than negative 4, you could choose negative 6. We have to choose an x between negative 4 and 0, you could choose negative 2. An x between 0 and 6, you could use 2. And something greater than 6, we can use 8. And you can use odd numbers too. It doesn't have to be the numbers that you see there. Okay. Now, as you can see, this minus sign correlates to this minus sign. This x squared correlates to this x squared, and x minus 6, and so forth, right? So when we're determining whether our function is positive or negative in a certain interval, because we have this minus sign for our example, we're going to replicate that minus sign in all the different intervals in that whole column. Okay. Now there is a little shortcut to this one, right? If you did negative 6 squared, you did negative 2 squared, you did 2 squared, and you did 8 squared, just think about it. If you take a negative number squared, it's going to be positive. If you take a positive number squared, it's going to be positive. So a neat little shortcut to any number squared is that your output is always going to be a positive number. Okay. Then what we're going to do is we're going to put negative 6. So negative 6 minus 6, is it positive or negative? In this case, it's going to be negative. Yep. Negative 2 minus 6, positive or negative? Negative 2 minus 6, positive or negative? Negative. 8 minus 6, positive or negative? This is positive. Negative 6 plus 4, positive or negative? Negative. Negative 2 plus 4, positive or negative? Positive. 2 plus 4, positive or negative? This is going to be positive. And we have 8 plus 4, positive or negative, which is positive. Okay. Then we got to figure out a whole bunch of things, right? So as mentioned in class, if you multiply a minus sign and a minus sign, right? So our output is going to be positive, right? So if for example, I did a positive times negative, that means our output is negative. So that's what we can assume for this part here. So if we multiply all the signs, our output is going to be a negative. Yeah. So I'll leave that there if you need to see that. Negative times negative is positive. Yeah. So negative times negative is positive. So you're multiplying a positive times positive times positive. So the output is positive. So this one is the exact same thing. It should be positive. Now this one, if you multiply a negative and 3 positive numbers, your output is going to be negative. Yeah. So now all we got to do is sketch. Okay. So the region where x is less than negative 4 is under the x-axis. It's negative, so that's going to be under the x-axis. We have the region from negative 4 to 0, which is positive. This is above the x-axis. The region from 0 to 6, which is positive. This is also above the x-axis. And we have the last region where x is greater than 6. This is going to be negative, so this region is going to be below. Okay. Now, again, what you could do as well is you could also check this in Desmos. So if I took this function that you see here, so I'm just going to take this out. I type in b of x equals negative x squared times x squared minus 2x minus 24. So as you can see, it's not exactly the same thing as what we have there, but in general, all the most important parts that we could figure out was, well, it goes down, goes up, then comes back, and then goes up, and then comes back down, which is shown over here. So yeah, so basically that's it then. Okay, so yeah, so Desmos is a very powerful tool for checking your work, if you're wondering. Yeah. And then the sign chart is also a very powerful method that can be used because you don't actually have to calculate a whole bunch of y values. All you got to do is just plug in the numbers into these factors and just figure out whether your function is above or below. Okay. If you have any other questions about this, just let me know. Thank you.